Hi there, Charger people. It's Mrs. Boyd. Today I'm coming at you with solving by graphing, aka finding the zero. Let's make a few relationships here, relationships between equations. We have a linear equation. We can write it negative 2x plus 6 equals 0. The exact same equation, I flip everything around and it's 0 equals negative 2x plus 6. Those are the same two equations. The same can be said with a function. If we write a function in function notation, f of x equals negative 2x plus 6, I can switch that f of x to y and have y equals negative 2x plus 6. These two equations are the exact same. One's in function notation and one is not. So now that we know that, let's talk about what a zero is. Zeros when we're graphing anyways. So the zeros, the zero or the zeros, either one, of a function are the values of x that make f of x equal to 0 or y equal to 0, which is located at the x-intercept, which is called the root. So 0, x-intercept, and root, all the same idea. The x-intercept is the solution to a linear equation. Let's put this into practice a little bit so it might be a little bit more clear. We've got this linear equation like we wrote above, 0 equals negative 2x plus 6. That's our linear equation we're going to start with. So now we need to get x alone. We've plugged in 0 for y is essentially what's happened here. So it's negative 6. We're going to subtract that from each side. We have 0 minus 6 is negative 6, and that equals negative 2x. 6 minus 6 cancels, and we just have negative 6 equals negative 2x. So we can divide both sides by negative 2, and that's 3 equals x, or x equals 3. They're the same thing. That's our solution. That's the root of this function. 1, 2, 3. That's where it crosses the y-axis, or the x-axis, I'm so sorry. If we have a function, y equals negative 2x plus 6, these are the same. One is just y, and one is we plugged in 0. So 0, 6 is our first point, because we know that is the y-intercept. So I can put 1, 2, 3, 4, 5, a point right there. I can plug in 1 for x, and I get y is negative 2 times 1 plus 6. Well, that's negative 2 plus 6, or 4. So when x is 1, y is 4. Or right there. I can plug in 2 for x, and I get y equals negative 2 times 2 plus 6. Well, that's negative 4 plus 6, or 2. So when x 2, y is also 2. And last but not least, we already know that when x is 3, y is 0. We found that before. So we can connect these with a line, something like that. And that's where we cross the x-axis is our solution. So we can say the solution to the equation, should be 2 in there, is the same as the x-intercept of the function. All right, so if you can find the x-intercept, you can find what we're going to call the solution. Let's do some more. Instructions here say find the zeros of the function. So what we're going to do to make that happen, we make y 0 because I want the x-intercept. Now I could solve for x. Let's add 2x to each side. Got 2x equals 160, and those guys cancel. Can divide both sides by 2. I get x is 80, and that's the 0. That's the root. So this has 3 names: 0, root, solution. Can be any of those things. Let's do another one. Y equals negative 0.5x plus 20. Well, we make y 0 again. And we solve for x. Let's add that 0.5x to each side again. I'm choosing to do that because my x is negative, and I know I won't have to deal with a negative number if I add it to each side. So 0.5x equals 20. Divide by 0.5. That gives me x is 40. So solution 0, root for this function is 40. All right, let's flip your paper over and do some word problems. Find the 0 of the function. Nathan received a gift card for trading cards from a local store. The function y equals 25 minus 1.95x represents the remaining dollars y on the gift card after obtaining x packages of cards. So same idea, we make y 0. Y is 25 minus 1.95x. We can add that 1.95x to each side. Get 1.95x equals 25. Divide both sides by 1.95. We get x is 1280. So if we make each of these lines 2, and x is 1280, that's almost 13. That's our x-intercept. We can plug in, we don't really need all that much. We know that our y-intercept b is 25. So if we make each of these lines 5, and every other line is 30, then we know our y-intercept is 25. Well, we can connect these 2 lines together. So close. That's not too shabby. And that's what our function looks like. Well, this tells us Nathan will be able to buy 12 card packages and have money left over, because 1280 is our y-intercept or x-intercept. So he can buy 12 card packages. He'd buy 12.8, but he could buy 12 and still have a little bit of money left over. Let's try another. Olivia wants to record her favorite songs to USB. The function t equals 60 minus 4.10 s represents the recording time t available after s songs are recorded. Again, we make our y variable, which here is all alone, t, 0. And that 0 equals 60 minus 4.10 s. We want to get s alone. So we've got 4.10 s is 60 Divide both sides by 4.10. We get S is 14.6-ish. All right. So we can let's make every other one 5 here. So 5, 10, 15, 20. That's 14.6. That's about right there for the x-intercept. We know our y-intercept is 60. So if we make every other one of these 20, our y-intercept will be 60. And we can connect the dots. That's what our function looks like. So we can tell from just the x-intercept that Olivia will be able to record 14 songs and still have some space left over. I'm sure you've calculated things like this before. If you've ever gotten like an Apple gift card or an Amazon gift card, how many things can I buy before I run out of money? You were doing this math and you didn't even know it. So, haha. All right, last one. Autumn uses a $20 gift card to buy coffee. The function m equals 20 minus 2.50c represents the amount of money still left on the gift card m after purchasing c cups of coffee. Again, we make m 0. And then we have to solve for c. So we add that to each side. So that's supposed to have a c with it. 50c equals 20. Divide by 2.5 on each side. And c is 8. We can make those each one. And our x-intercept is 8. We can also see here our y-intercept is 20. If we make these like that, we get 20 at the top. And that's how our function graphs. We can also know that Autumn can purchase exactly 8 cups of coffee and have no money left over. All right, so I hope these make all sorts of sense to you. I hope you're doing amazing. Find me if you need help, and I hope to see you soon.